C'est toi qui conduis les débats.
Okay, so are you all ready, right?
Yes.
Yep.
Okay, so we can start. So good morning, everybody. So today we're here to listen to Romain Mathonat, who is going to be defending his PhD work titled Rule Discovery in Labeled Sequential Data, Application to Game Analytics. So I'm going to, so there's a committee, and the committee has two rapporteurs and a number of examinateurs and examinatrices and the thesis supervisors. So the rapporteurs are Professor Martin Admüller from Osnabrück University, Alexandre Termier who's a professor in Rennes. Then we have also as examinateur and examinatrice Germain Forestier, who is a professor at University of Alsace, Anne Laurent, who is a professor at Université de Montpellier, and Shedi Raisi, who is chargé de recherche at INRIA and Ubisoft, and myself. And then as supervisors, co-supervisors, Jean-François Boulico, who is a professor in INSA Lyon, and Mehdi Kaitou, who is a maître de conférence at INSA Lyon and also Infologic R&D. And I am Sihama Merehia. I'm a directrice de recherche CNRS in Grenoble. So Romain, you have 45 minutes to present your work.
Okay, thank you, Mrs. Anaya. So good morning, I am Romain Mathonat, and I am here today to present you my thesis work titled Rule Discovery in Labeled Sequential Data, Application to Game Analytics. So this thesis has been conducted and in collaboration with Atos and has been funded by Atos. So we are in an industrial context with different clients. Example of such use case with these clients are the urban farming, where we want to find the best condition for vegetable growth, or the predictive maintenance of cloud environment in order to prevent failures. From those two use cases, two main needs emerged: the need to better understand them in order to emit hypotheses on the why an event appears, but also to better predict in order to anticipate what will happen. If we take a closer look at the use case on the industrial context of failures in a cloud environment, we can in fact label sequences of events like this example. We have the CPU and the random access memory over time. And at one point, there is a failure. And what we are looking for are those patterns in red here that is characteristic of such a failure. This is interesting in order to understand why this failure appears. So maybe it will help us to solve this problem, and it will be interesting to better predict it in the future. So in this context, we encountered sequences of events, time series, but also numerical data. However, due to confidentiality issues, we decided to illustrate our results on game analytics, and this for several reasons. First, because the sequentiality is important, and we have sequences of events. We also have physical object trajectories in game, so we are in fact in presence of time series. We will have to deal with scalability because we will have huge search spaces, and there is also the presence of noise. Note that raw data are freely available, which is a good point for us. So the game that we are going to take interest in is Rocket League. So it is a very popular game, which is basically football with a little car that you can control, like you can see here. So we want to identify sequences of action from game traces and player inputs. So for example, here you will have a move where I climb up the wall, I make a pass to my teammate so that he can score. This is a particular move that we want to be able to detect. So from those use case needs, we can describe the generic problem we want to tackle with this generic illustration. So we are looking for the best patterns characterizing a class. So we are in presence of a data set with objects, each object being labeled by a target class, here a red or a green point. And we are looking for pattern. Note that the subset of dataset objects covered by a pattern is called its pattern extent. to judge the quality to assess the quality of this pattern, we use what we call quality measure, for example, the precision or the weighted relative accuracy that I'm going to detail a bit because we are going to use it in the thesis, in the presentation. So it is a weighted, so the first term is in fact the frequency of the pattern, relative, so a difference, accuracy, in fact, is precision, but it's for history, but here we have the precision of the pattern minus the proportion of positive elements in the database. Note that its maximum value is 0.25. So note that depending on the number of objects of the dataset and on the complexity of the pattern language that we choose, we will have issues with scalability. So we need to take that into account. And the genericity is also important to deal with different pattern languages and different quality measures. More specifically, we are looking for the top K non-redundant interpretable rules or subgroups in labeled sequential data. So here we have an example of a sequence of item set that you can read like a music sheet from the left to the right. So each vertical slice is in fact an item set. So here we have gray and brown, then gray and blue, etc. So we have data sets with sequences like that, and we are looking for pattern or subsequence in that case that are predictive, that are characteristic or discriminative of this class. So to deal with this problem, we propose several contributions. From an algorithmic point of view, we propose to tackle the problem of supervised rule discovery in sequences of item sets. We also tackle the problem of supervised rule discovery in high-dimensional numerical data. Those algorithms share several characteristics. They are generic, they are anytime, so you can stop them at any time, they will give you results. They are agnostic of the quality measure, and they are efficient because they have to deal with huge subspaces. From an application point of view, we applied our work to a player behavior detection use case, and we also worked on urban farming optimization. In this presentation, the use case we will focus on is the player behavior detection. So the outline of this presentation is the following. First, we are going to introduce the state-of-the-art of supervised rule discovery from an algorithmic enumeration perspective. Then we are going to introduce the Bandit model and the Monte Carlo research in order to better understand our contribution that I'm going to describe after. Then I will present the application, and finally, I'm going to conclude. Okay, so for the state of the art. So here is a representation of the search space that I chose inherited from item set mining. So on the top, you have the T pattern, which is the more general pattern covering all objects of the data set. And the more you go down in the search space, the more specialized patterns are and the less object they cover. So for example, if you take sequences of item set, the more you go down in the search space, the longer sequences are and the fewer elements they cover. So the first proposition to deal with this problem that we have is the breadth first search, which is an exhaustive algorithm, top-down. But with this kind of algorithm, we will have issues with huge search spaces. Another exhaustive algorithm is the depth first search, but by definition, again, we will have issues with huge search spaces. Another family of algorithms are sampling algorithms. For example, Miser is an example of such an algorithm. It is an heuristic that is bottom-up and that is based on pure exploration of the search space. It is simple and gives results. It gives pattern having non-null support. There is also the beam search, which is a top-down heuristic, which is basically parallel greedy search, which gives results of quite good get quality, but that is greedy and fully based on the exploitation. We have also the MCTS, which is an algorithm that proposes a trade-off between exploration and exploration, which is a top-down algorithm that I'm going to detail a bit after. So the limits of the state of the art are the following. For the Vim search, it is based on the exploitation only. It is greedy, and we have a parameter setting, which is the Vim width. We have Misère, which is an algorithm based on the exploration, which is fully random. And we have MCTS-4GM, which is a top-down algorithm. But without printing, you note that we will have issues with very large search spaces. So we have a trade-off between exploration and exploitation. So this will naturally lead us to the bandit problem and the MCTS. So I introduce this concept in order to better understand our contribution. The multi-arm bandit problem is the following. We have a slot machine with n arm that we can pull to get money. So here you have the representation. If you take a look at the top right arm, we pull it once, we get $53. We play it again, we get $28. So this is to illustrate the fact that each arm has its own unknown probability distribution. And the problem is, what is the best strategy to maximize the reward? So at each iteration, what should be the next arm to play in order to maximize the reward? Auer et al. Proposed an algorithm to deal with such a problem, which is called the upper confidence bound, or UCB, which proposes a trade-off between exploration and exploration. These two terms here and here. So the idea is to compute this upper confidence bound for each arm and to select the one maximizing it. So here you have a representation of the algorithm at step 3. So we have 3 slot machines, each one with its own unknown probability distribution at the beginning. We are at the step 3 of the algorithm in order to better understand how it works. The yellow point represents previous sampling from previous iteration, and the vertical yellow line represents the estimated mean reward of this slot machine. So here, the best estimated mean reward is on the first one, and the UCB is then the best on this one. So we select it and we play it. We get a new result, so a new yellow point, updating the mean reward. So now we compute its new UCB, and now the best UCB is on the third slot machine. So we play it, and we have a new estimation. So after iteration, we converge toward better estimation for the mean reward. From the UCB, an evaluation has been proposed, which is called the Monte Carlo tree search. So the Monte Carlo tree search is a technique coming from game theory to explore a search space following a trade-off between exploitation and exploration. So I'm going to detail to explain it from a pattern mining perspective with the algorithm MCTS-4GM that has been proposed by Guillaume Bosque. So note that this represents a node, so a pattern. We begin with the T pattern, so the pattern at the top of the search space covering all elements of the dataset, and represent the number of times we perform the full MCTS cycle on this node, and Q is the estimated quality of this node. So the first step consists in selecting a node. So we select this one, then we expand it, meaning we create a children node, so a pattern that is a bit more specialized than this one. After that, we roll out it, meaning we go down much more in the search page, creating a new specialization of this node. We compute its quality measure, which is quite bad here, and we update it. We update the parent node with this quality measure. This means if we try to go in this direction in further iteration of the MCTS, this tends to bring us to pattern of bad quality, so try somewhere else. And then we perform again a full MCTS cycle. We select the T pattern, we expand it, we roll out, and we update. Now we can see that we have a better quality measure. So we update the parent node. We do that again. We select the T pattern, we expand, we roll out, and we update. Now that note that in fact the select is a recursive procedure that we select the best node to expand in further iteration. So once a node has been fully expanded, it selects one of its children following the UCB. So now the node having the best UCB is this one because the maximum value in fact here is here. So we select it, then we expand it, and again we roll out and we update the value of node parents. After more iterations, the tree grows asymmetrically toward interesting area, like you can see in this illustration. However, we try to apply this algorithm on sequences of item set, and we realized that it worked poorly because, in fact, it has issues with huge search spaces. So our first contribution is then on the subject of mining interesting rules from sequences of item sets. So here you have two sequences of item sets, and this is just an illustration to see how difficult the problem is. So in fact, here you have those two sequences of item set, and we are looking for patterns appearing in those sequences. So just visually, you can have an idea of the complexity and the size of the search space, which is very important. In fact, a message that I want to give is that we do not need petabytes of data to face an intractable problem. For example, the number of possible sequences for this kind of data has been, we know we can compute it. And for example, if we take the dataset promoter, which is one of our benchmark datasets, with DNA sequences of length 57, we get a search space of the order of 10 power 41. So clearly, this is a huge search space that we have to deal with. So to deal with that, we propose to use a key property, which is the following. If we take a dataset object, or even a pattern, and we remove restriction on it, this will create a new pattern covering at least this element or the element from the initial pattern. So it will have a non-null support. So we are in presence of a difficult problem because for sequences, the search space is huge with a vast majority of patterns being of null support. So we take advantage of this key property. The first algorithm that we propose is called SexCount. So in the case of sequences, the pattern language that we are going to use is the pattern language of subsequences. So we say that SB is a subsequence of SA if we can build SB by deleting items of SA. So for example, if you take B then A, it appears in S1 because if you remove D, W, S, and C, this creates B then A. However, if you take the sequence of only one item set BA, you can remove all elements that you want in S1, you cannot build it. So it is not a subsequence of S1. So our algorithm now, just a little note here, the search space here is a bit different because we are dealing with sequences of item set, and in fact, we chose to represent it this way because all elements here are elements of the data set on the bottom of this representation. So first, we filter all positive sequences of the data set. An important thing to note is that we will consider each dataset object as an arm of our multi-arm bandit. So the first step consists in selecting the best second to play with respect to the UCD. And we then play it. So we generalize it by deleting random items. So we took this sequence, we randomly remove some items. So this visually, this consists in going up in the search space. So this creates a new generalization, a new pattern having a non-null support covering at least a positive object. So we then compute the quality with the quality measure, and we update the UCB value of this node. And we do that again and again until we have no time budget left. We compute the UCB and we select the best one. We generalize and we do that again. Once we have no time budget left, we finish and we filter elements to make sure we have patterns that are non-redundant following the JACA index in order to present a few patterns non-redundant to the end user. Finally, we perform basically an hill climbing procedure to optimize the pattern obtained in order to find local optimum. And we get those top K patterns. The pros and cons of such an approach is that first, it generates only patterns having a non-null support, which is interesting. It is an anytime algorithm, so you can stop it at any time, it will give you a result. It also does not require parameter tuning, contrary to beam search, and it is agnostic of the quality measure. Note that it will be less efficient if we have too much dataset object. In fact, we need to have much more iteration than the number of objects in order to take advantage of the UCB, but it will at least give us pattern having non-null support. The second algorithm we proposed is called MCTS extent. So in fact, we propose an approach that is based on the UCB, but we are dealing with a search space. So in fact, we can propose a Monte Carlo approach. So at the beginning, the algorithm begins the same as SexCount. We filter all positive sequences of the dataset. So here we have a representation. We are in a bottom-up way. So each node 1, 2, 3 represent one is the object 1, the object 2, the object 3 associated to the pattern covering it. We are under steps 3. We take a little iteration further in the algorithm in order to better understand what is happening. So the first step consists in selecting. So we selected the node 3. Then we expand it. So now to expand the node, we will add a new positive node to this node. Here we selected the node 2. So now we have a node with 2 elements. We need to compute the most specialized pattern covering those 2 elements. And in this case, this is called the longest subsequence between sequences of item sets. So I'm not going to detail it in this presentation, but in fact, you can look at it in the thesis. We propose a dynamic programming to compute efficiently a longest common subsequence between sequences of item sets. So we will then create a pattern that covers 2 and 3 at least, but in this case, it also covers 1, the object 1. Then we roll out it, so we generalize this pattern the same way as we did with SexCount, and we update, like in the classical MCTS. We perform that full MCTS cycle again and again until we have no more time budget left. We filter interesting objects or interesting patterns with non-redundancy. We remove the redundancy. And finally, we get the top K patterns. So this algorithm is interesting because, like SexCount, it generates only patterns having non-null support. It is anytime and agnostic of the quality measure. But now it gives more guidance in the search space, and it requires no parameter tuning. So for the experiments, we experimented on several datasets. Note that here I only present some experiments, but you can refer to the thesis. There are huge work on different experiments. So we have different datasets with different search spaces here. And you can see that it is, in fact, an intractable problem, it seems. So here we plotted the mean weighted relative accuracy of top 5 best patterns for 60 seconds. So how good are these patterns? How discriminative they are? We compared against MISER, against beam search, so an adaptation of beam search to the case of sequences of item set, and we have SexCount and then MCTS extent. So we can see that MCTS extent gives best results in most of the cases. So because it guides better the search, leading to better results. Note that on the dataset splice, beam search performs really poorly. So if we plot it, if we plot the average weighted relative accuracy for top 5 patterns versus iteration on this dataset, we can see that indeed beam search performs really poorly, and we quickly converge towards interesting patterns. So in order to better understand why, we plotted the length of top 5 best patterns, and we can see two interesting things, mainly two interesting things on this graph. You can see that on the dataset GMLR, which is composed of sequences of abstract, sequences of words of abstract of the journal GMLR, the best patterns seems to be of length 1. So in fact, the sequentiality has no importance in this dataset. Another interesting thing to see is that on Splice, you can see that beam search only finds patterns quite short, whereas the best ones are of a greater length. So it seems that beam search has issues to find a pattern, really long patterns, which are more interesting in this case. So to summarize, we proposed algorithm for the top K supervised rule discovery for sequences of item set for the discovery of top K. The first one is called SexCount and uses directly the UCD-based approach, which performs quite well. And after that, we propose MCTS extent, which guides the search using MCTS and performs better. So now, as we encountered, in fact, sequences of numeric, which are in fact time series that we propose to transform into numerical data, we are going to take interest in the subject of mining interval patterns from half-dimensional numerical data. And the algorithm to deal with such a problem has been named NonTech. So here we have a data set with numerical data, and we are pattern language, which is the interval pattern. So the pattern P is here an interval pattern, which is in fact a restriction on intervals. We have intervals for each attribute. And we say that the pattern P covers an object if all attributes are within the range of each corresponding attribute. So here we have P that covers the object O1, O2, and O3. We propose to transform time series into high-dimensional numerical data in the following way. We have here a time series of length 3 with two values at each timestamp, and we transform it this way. So the idea of Monte Carlo is to use a bottom-up Monte Carlo tree search on closed on the positive only for interval patterns. So here is a visual representation of closed on the positive. So I chose to only keep the attribute 1 and 2 in order to represent in 2 dimensions what is happening. So in the 2D plane, we have those green elements and the O4, that is the red element. In fact, in 2 dimensions, a pattern is in fact just a rectangle. So the P patterns covers the element O1, O2, O3, and it is a co-TP because if you try to reduce the size of the rectangle, like here or like here, this leads to a decrease of the number of positive objects it covers. So any pattern whose restriction on an interval leads to a decrease of the number of positive elements is covered is a co-TP, a closed on the positive. And why co-TPs are interesting? Because they reduce the search space size and they keep the most discriminative patterns that are the ones that we are interested in. We also need to introduce the meet operator. So the meet operator is the smallest axis-aligned rectangle that contains both patterns. So the meet between 2 patterns, you have an example here. We have the closed on the positive pattern PO2 that covers just the object O2. We have PO3 that covers only the object O3. And if we compute the meet, we compute in fact the minimal rectangle covering those two patterns. So here it is here. And one interesting, so in fact, the meet consists in taking all intervals and taking the maximum value for two patterns. And the key property that we are going to base our algorithm on is that the meet of two cotypes is a unique cotype. And we will use this property in the Monte Carlo research to explore only closed on the positive. So if we again take our representation of a bottom-up Monte Carlo research, if we take the expand step, we now have a node with 2 and 3, which are numericals, and numerical objects. And we need to compute the more specialized description, the more specialized pattern that covers them. And in this case, this is in fact just the meet. So we compute the meet. We compute the meet of 2 and 3, and this creates the node 1, 2, 3. In fact, we have the meet of O2, O3. This creates this rectangle covering also O1. So this creates this new pattern. After that, we roll out this pattern. So we go up in the search space again. Now the strategy is a bit different than from previously because we have a new pattern language. The strategy is the following. We take a random interval. We rhythm it with random values present in the dataset and set all other intervals to no restriction. After that, we update the parent node and we perform the MCTS cycle again and again until there is no more time budget left. So this algorithm has several guarantees. It explores only cotype and it is exhaustive on them if given enough time. It has the property of it is anytime, it is an anytime algorithm, which does not require parameter tuning and is agnostic of the polyturnation. So for the experiment, we experimented on several data sets, as you can see here, with different search space sizes. And here is the main results. It is the mean weighted relative accuracy of top 5 best patterns for 60 seconds with different algorithms. So we compared against MISER that we adapted to this case with beam search. And we also compared against MCTS-4GM because it can in fact deal with purely numerical data. So we are in grid and we can see that we have outstanding performance on nearly all data sets. So this algorithm seems to work very great. We plotted the normalized weighted relative accuracy versus time on UCG 500, one of our datasets. And we can see that, in fact, we converge rather quickly towards interesting results in green here. Now that I have presented the algorithmic contributions, we will look at the applications. Okay, so we have an application with game analytics, and our goal is to create a system that automatically detects skill shots in real time from game traces. So the esport and game industry is something important now. We have more than $100 billion in 2018 in this industry, which is growing with billions of gamers in the world. In particular, with Rocket League, we have 60 million players in 2019, hundreds of thousands cash prizes, and a lot of professional teams. So what is the interest of detecting skill shot? This will enhance player ranking system because just like in chess, we have an Elo score that is purely based on the win and the loss of matches. So we could detect the skill of player to better rank them. We could help commentators recognize skill shots because they are public matches with analysts. So we could help them to recognize skill shots to better inform the public. And skill shots are in fact important in game to take advantage of your opponent. Think of the nutmeg in football, for example. So it is important to learn this skill shot in order to be better. So we could help players to be better with such an approach. Finally, we could also create new game modes like the horse game and basketball, for example, where we could perform predefined figures, predefined skill shots. So here is a representation of a skill shot called a ceiling shot. So I hit the ball, I climb up the wall, I climb up the ceiling, I jump, and I hit the ball in the air, putting it inside the opponent goal. So this is the first instance of a ceiling shot. Now here is a second instance of a ceiling shot where I also hit the ball, I climb up the wall, I climb up the ceiling, I hit the ball in the air, and I put it inside the opponent goal. So just visually, for someone playing the game, it is quite easy to know that those are in fact the same skill shots. But for a computer, it is much more difficult because here is in fact the button that the player pressed during the performance of each of these skill shots. And we can see that visually, this is very different. So how can, from that, can the computer, the program, detect that this is the same skill shot? Note that here we have the legend, so each screen, each colored square corresponds in fact to a button. So we are looking for patterns discriminative of this skill shot, so patterns covering instances of the ceiling shots, but which are not present in other skill shots. So to deal with such a problem, we proposed the following. We proposed and implemented the following workflow. First, we listed the skill shots that we wanted to detect, to be able to detect. We then perform a data collection step. Then we augment those data and we label them. After that, we perform the pattern mining step. And with these extracted patterns, we record the data set that we can finally use in a supervised classification. Note that all code, data, and example, and video example are available at the GitHub repo below. It is freely available. So first, the data selection. After listing the skill shot that we wanted, we have the data selection. So in fact, in Rocket League, we can save replays and we can decompile them into a larger sequence of those blocks, at different time steps. And for each time, we have for each object of the scene, so each player, and the ball, its position, its rotation, its linear velocity, etc. So in fact, we can transform that doing some feature engineering to compute new features like the distance to the wall, distance to the ceiling, the ball speed, etc. We call that contextual informations. After that, we added from those data another data source, which is the inputs of the player. So what buttons does the player press on its controller? So we collected them with a self-made program that we wrote, and we merged those data with contextual information from the previous step, leading to data of this form. We have for each skill shot a sequence of state, each state being of the following form with an item set of button pressed and contextual information, so the feature that we computed before. We also labeled, so we played with the player and we labeled each sequence with the corresponding skill shot. This created our data set. Now, for the pattern mining task, we are looking for what we call behavioral pattern. So it is a subsequence of state. Now, the pattern language is a bit different from the sequences of item set that we presented before, because now we have, for example, the green pattern, so with an item set with interval patterns, appears in the object on the right. And note that we can obtain the pattern here, from this object by removing B and transforming numerical values into wider intervals. So this is the rollout step that we used with the algorithm SexCount. In fact, we adapted the algorithm SexCount for simplicity to this use case, to this pattern language, to extract interesting patterns. So once we have these patterns, we recode the data set using an instance of the Lego framework. So for each pattern will correspond to an attribute. And for each pattern and for each object, we set its value to 1 if this pattern appears in the object. Finally, we train a random forest classifier on this dataset to make the predictions. So the results are the following. We created a new dataset of nearly 300 sequences with 7 classes. And we reached a mean accuracy of 87.6%, which is quite good. We note that we compare against one nearest neighbor dynamic time warping because, in fact, we can transform the dataset that we had into multivariate time series. We can see that we had better accuracy, much better accuracy, and also that we classify in real time, contrary to one NN dynamic time warping. So it is now time to conclude this work. So the story of this thesis is the following. First, we try to apply the algorithm MCTS-4GM for sequences of item set, but it worked quite poorly. In fact, Miser performed well, but could be improved. And the reason why Miser performed better is because it has this key property of selecting object and generalize it to create rules. So we proposed, in fact, bottom-up algorithm to deal with this first problem of mining rules from sequences of item set. We proposed SexCount, which is an algorithm using this key property of Miser, using a UCB and an hill climbing, optimizing, and ad post-processing. After that, we realized that, in fact, we had UCB with a search space, so we could, in fact, use MCTS to explore the search space. However, we needed something else because, in fact, in the MCTS, by definition, we were creating interesting patterns because we were grouping positive objects. So we needed now to compute the most specialized pattern covering those objects. And that is why we needed to compute the longest common subsequence for sequences of item set. We did not find an efficient algorithm to do so, so we proposed a new one. After that, because of the use case we were working on, we needed to take into account high-dimensional numerical data, and we realized that we could apply a similar approach that MCTS extends, but now only enclosed on the positive. And so we proposed the MIT and the adaptation to this algorithm to create MonteClopy, which explore only CoTP and is exhaustive on them. Finally, we apply our work to a player behavior detection use case with Rocket League, where we proposed a complete data science workflow with the dataset creation. For the perspectives now, in the use case of Rocket League, we have the problem with the noise, because in fact we created a class which we called noise, which were in fact composed of random moves and phase figures. And if we took a closer look at how our classifier worked, and it seemed that it performs very well when we want to classify the intention of the player, and badly if we want to classify the failure or not of this intention. So in fact, we could add a new label to this dataset, which consisted the failure or not of a skill shot, and we could use this approach to classify the intention, and another approach to classify the success. Another way of improvement would be to automatically detect new skill shots, because in a game such as Rocket League, the community create new skill shots over time. They discover new things that they propose. So the automatic discovery of such a skill shot would be of interest. From an algorithmic point of view, I realized that we could in fact improve the rollout step of MonteClopy to cover only closed on the positive. In fact, actually, it creates a new random generalization that is not a CoTP. So we could do it the following way. First, for a node with 3 positive elements, we compute the set of, we take all the positive elements of the data set and we remove those elements. We remove k element of this set. We make the union with the initial element, and we compute the mean of this set. This would create a pattern covering at least the initial element, so it will be a generalization, and by definition, this will be a co-TP. Note also that we can compute, in fact, the number of co-TP that we can compute for each level of the search space with this formula. So in fact, we could use the rollout to compute another tree at the top of the search space level-wise when performing rollout. So we would have Monte Carlo tree search growing bottom up and another tree growing at the top until they reach each other, meaning that we have a complete exploration. Finally, another perspective is that, in fact, we propose the framework or the automatic discovery of interpretable rules characterizing a target class, also called discriminative pattern mining. And to do so, we could apply to other pattern languages like Rust. We could redefine the meet operator to desired pattern language. So we need to compute for each pattern language the most specialized pattern covering initial patterns. We need to redefine the rollout step to desired pattern language, so the generalization step. And we could redefine or select another quality measure depending on the needs, on your needs. So thank you for your attention. If you have questions, I'll be happy to answer them.
Okay, thank you, Romain. Thank you for keeping the time. We're going to start with the series of questions. I guess the very first person I'm going to invite to ask questions is Professor Martin Zmöller from Osnabrück University. So Martin.
Okay, yeah. Thank you very much, Romain, for this very nice presentation. And I want to say I'm very honored to be on this committee. And also to have this opportunity to be the first to ask the first questions, essentially. So in your presentation, you mentioned several times for the different algorithms that the algorithms were agnostic on the applied quality measure. Can you say a little bit more what you mean by that? So what means agnostic in this sense?
Well, it is agnostic as long as you want a quality measure that is discriminative, because in fact, if we look at the MCTS extended algorithm, for example, the goal is to find pattern characteristic of a target class. So we group positive elements together. So by definition, what we are creating is discriminative patterns. So any quality measure that measures the discriminativity, like the growth rate, the precision, the F1 score, or the weighted relative accuracy would work. If you would like to compute quality measure, like in fact just the support, I'm not sure this would work as well, but we have other algorithms to deal with such a problem.
Mm-hmm. Okay, yeah, because I was wondering about some, let's say, there's for pattern mining, there's also this idea of exceptional model mining. So you could, for example, also include several target attributes or look at more complex models. Mm-hmm. So would the algorithms also work with this?
Yeah, it would work with this. There is a difference though. Here we have filtered only positive elements and we grouped only positive elements in the case of exceptional model mining. So exceptional mining is basically a generalization of subgroup discovery. You look for interesting pattern that cover a subset of objects, and on this subset of objects, you need to find a model that is different from the model from the old dataset. So now we do not need to take into account just positive objects, but now we have to consider all possible objects of the dataset. So the basic approach would be to apply this algorithm to all the data set of objects. Another maybe more smart way would be to use heuristics depending on the EMM instance and on the exceptional model mining instance that you have. We could in fact develop heuristic to select the next object that we want to add to a pattern, because there may be dataset objects that are more, that deviates more from that we make the distribution, the model deviates more than others. So depending on, for example, if you take linear regression, we could propose an heuristic like computing the slope between one of the initial node of the pattern and a new node that we propose. So it is a very rough estimation. And you select a new node, the new object, sorry, that will create a slope that is more different from the general slope of the dataset. I don't know if it is clear or not, but the idea is that you could use heuristic to select the next object to add to this pattern to converge quickly to interesting patterns.
Mm-hmm. Yeah, so this might work for these extended quality measures. So
yeah.
So now with my questions, I'm at the moment I'm let's say quite close to the presentation, but I was also wondering about the modeling for the patterns that you apply, and also about the pattern language, because in the introduction you said, okay, we can go for detecting interesting patterns regarding events. So for example, also for predictive maintenance and this urban farming. And of course, so these events itself, they have something like a timestamp, right? But when you turn them into a sequence, you basically get the ordering of the events. Can you maybe say something on this modeling, on the limitations, and where you see that how this might be, let's say, extended?
Yes. So indeed, this is a clear limitation of what we propose. We remove the timestamp, and so now we have only the ordering. Actually, at Atos, I applied it on another use case, and the person asked me, but in fact, yes, we have pattern, but we want to know the gap between events of this pattern. So the basic approach that I proposed, which is in fact quite quick and dirty, was to compute the statistic on the dataset. So in what was the mean between the mean time between two elements, so I gave it them. But in fact, we could enrich our pattern language to deal with other pattern language like chronicles, or for example, chronicles, or just make restriction on the gap. So the first step will be to add a restriction on the gap, saying that we want patterns with a gap of at least, let's say, 3 units of times, something like that. But we could also use chronicles where we have sequences of items, of discrete items with a restriction on the time between them. But now we will have a new pattern language, so we will have to redefine the meat, which is a bit more complex, and in this case, and we will have also to redefine the rollout.
Okay, so this is basically what you described in the very end. So these extensions, if I get this. So this would also work directly with all the algorithms that you presented.
Yeah, I think this is the strength of this approach. It is because it is, yes, quite generic. So it seems to give good results. So I think, we could apply to some other cases, yes.
Okay, very good. So I have one further question at the moment, because this was also very interesting from the beginning, where you said, okay, basically you get to these patterns. So these are descriptive, of course, but then you somehow turn them into a predictive model. So my assumption would be that this is extremely useful for the secret application cases that you did not tell us about, but you also said something about this for the game, and you actually also presented this with the random forest and so on. but I was wondering, so in this, I mean, this predictive modeling, this is actually a step on top, right? And you need to make some decisions. For example, one thing that you need to decide is which set of patterns actually to include in the predictive model. Can you say something about this? So about this general approach and how you approached it?
Yes, indeed. In the paper, we performed several experimentation because indeed we have several degrees of liberty with such an approach. We have the number of patterns that we select. So first we have to mine patterns for each class. Then we have to select the number, to set the number of patterns we mine for each class. We have to select the algorithm for the classification. So we tried with random forest, with gradient boosting, we tried with decision tree and SVM, from what I recall. You have to set that. You have to set also the non-redundancy threshold that, so actually in the experiments we tried, and it seemed that it did not really affect the classification results. And for the number of patterns, we basically performed a grid search for the pattern for testing all those parameters in order to have the best classifier. But yes, from what I understand in machine learning, it is a problem that we have quite often, the setting of parameters or hyperparameters, and here we have some that we have to set. Yes.
Okay, good. So thank you very much. So I think for the questions, I would then,
Thank you for your question.
Pass this on to the next one.
All right, so the next person I'm going to invite for questions is Alexandre Termier, who is a professor in Rennes. Alexandre?
Thank you. So, Romain, first I would like to thank you for a very well written document. It was really a pleasure to read, and I learned a lot on pattern mining algorithm in subgroups with MCTS.
Alexandre, your voice is a little bit faint, so if we could,
Yeah, I will turn the mic so like you can hear better.
Is it better now? Yeah. Can you hear me better?
Yeah, thank you.
Okay, I will have to shout. Or not. So, okay. Now Romain gave me the mic, so it should be better.
Much better, thank you.
Yeah, thank you, Romain, also for bringing the mic. And okay, so thank you also for the very clear presentation on what's not to like in a presentation which starts with the games and then presents pattern mining. It was really a good day to come. But also I have questions. So, which will be more on the technical side first. So, in your SexCount algorithm, you have this rollout phase, and you will remove some items from your patterns, and you have a strategy for remove, which is basically I toss a coin, and I have equal chances to keep or to remove the item. And I thought, when you do that, it seems that you are somehow biasing your search towards mid-size item sets. It will be difficult for you to find very small ones, and it will be difficult for you to find very big ones because of this bias. So, okay, you had good results, but I would like to know if you could find some cases where indeed this bias was impairing you. Because of course, having good results is nice, it makes pretty on the picture. But there are some cases where you may have problem with this bias. So have you found them?
Well, actually, I think I tried two different strategies. So there is this one of tossing a coin for each item.
Just wait a bit. Siam, do you hear Romain well? Because he no longer has a mic.
I will take the mic back here.
Not as well as you, but...
Okay, that should be better here.
Yes, thank you.
I will give it back to him after if needed. So I tried two strategies. So the first one is indeed that we used is to toss a coin indeed for each item, and to remove or keep it. So in fact, I think this would correspond to a Gaussian distribution. We also tried another, so it tends to go in the center of the search space. I also tried with predefining the number of objects I want to remove and removing them randomly. So now that would be uniform in the search space. In fact, it seemed that we are better results with the first one. That is why we use that. Another answer to this question is that indeed, this is true. We could have issues with finding of the best elements if they are at the top of the search space, but we have this hill climbing step in order to optimize the pattern and the post-processing. So this tends to find them if we did not reach them in the first step.
Yeah, I think it is what saves you in many cases. Avoid you to go back and forth. Don't do anything.
Yeah.
Okay. So now, okay, I got several other ones. Okay, a short one to start on Rocket League. On Rocket League, first, I had also to say that you did a really nice and unfunny work, which was to make the data sets. I mean, of course, okay, you had to play for making the data sets, it's nice, but then the labeling, the cleaning up, I guess it was not as funny as making the data set, and it's very nice that you gave it to the community on a nice public repository. This is really useful. Now, when I saw the settings that you had for Rocket League, I thought that, okay, there are many work in deep learning to analyze trajectories. Disclaimer, I don't know anything about it. But I thought that, okay, there are so many people working on trajectory analysis that it would have seemed something. Have you looked at it, and could it have been used?
Actually, I did not really look at it. I looked a bit at it because I found that in the first case, I thought that we could use patterns because they are interpretable and they are in fact buttons of the player pressed. So I thought that maybe we could use the pattern not only to classify but to play, because in fact we have the sequences of action and maybe we could use that to play. So in fact, I did not have time to really try this problem because this is a much more difficult problem than just doing that. Actually, for the deep learning approaches, I think there was some reinforcement learning applied to Rocket League, and it performed really badly. So we have in game, we have some AI that are basically rules saying like, very basic rules saying like, okay, go to the ball, rush it as fast as you can, or something like that. In fact, in Rocket League, there is also competitions of bots. You can code in Python to create bots, and you make them fight against each other, matches against them to find the best. And the deep learning approaches worked worse than those engineering way from what I saw. So
yeah, but okay, the bots are not really what we are interested in now, because okay, you have this. You advocated well in the beginning of your chapter. You said, okay, we have these trajectories to understand plus the buttons, and we have to accommodate for some change in the shape of the trajectories.
yes.
So we will have this interval, and of course, deep learning is super good for that and will beat any pattern mining approach.
Okay, I did not understand the question. I understand now. Yes, we could, but we have an issue here, is that the labeling step is very costly. And in fact, in deep learning, so I took a bit of interest in deep learning during my thesis. I did the courses with Andrew Ng of Stanford. because it is important in our domain in data science now. So from what I understand of deep learning, you need let's say you need big data, you need a lot of data. And in our case, and in real cases too, the labeling step is very costly, and you cannot have millions of data. Here we have only 300 sequences, and as you said, this was a step that required a lot of work, a lot of dirty work.
Okay, you have got your get out of jail card.
So yes, apply deep learning on this. We could try it, but
not 300. It's okay.
I think overfitting is an issue.
Okay, I will stay on this this chapter. So you have. So I will go on the. It's a bit strange. You have presented us a nice sequence, an algorithm that works well on sequence, so SexCount. You have shown after Monte-Clopi, which works very well on numerical data, and then the data of Rocket League is a bit sequential and a lot of numerical. And you say, okay, but Monte-Clopi does not work so well, so we dismiss it, and you make some ad hoc modification of SexCount.
Yes.
So I understand that there are time problems and you had to do something that worked in a short amount of time. But if you had time for a new PhD again, would there be, don't worry, it will not happen. If you had time, would it be relevant to, for example, mix Monte-Clopi or MCTS extent to make the perfect miner for Rocket League or this kind of stuff?
Yeah, actually, I was a bit surprised because in the paper of Monte-Clopi, we applied it indeed to Rocket League and we gave it a lot of time. But it performed a bit, not by a large amount. So it was something like we reached an accuracy of 85%. And I think it is something like that. Whereas with the SexCount adaptation, we reached of 87.6. So it is not very different, but at the first glance, I thought that it would be better because the algorithm is smarter, it explores better. And I think the answer is in the rollout step and in the optimization step that we have in SexCount that we do not have in Monte-Clopi. And this optimization step of hill climbing to find local optima, I think it is that find much more interesting patterns in this case, in this particular use case, that leads to a better classification. So note also one thing, this post-processing hill climbing step can take a lot of time and you cannot predict how long it will take because this depends on the size of the search space. So it is quite difficult to use, in fact. So you need to have a lot of time. And for Monte-Clopi, however, I think that using the final approach, using only CoTP with the rollout now to create building this tree at the top would give, I think, better results. And so, in fact, I did not mention it here, but if we optimize the rack, the better the weighted relative accuracy of pattern, the better the classification in general. So I think yes. Actually, it does not perform better, but with the optimization we give there, it would, and we could also apply the post-processing step of SexCount to Monte-Clopi too. In the paper of MCTS extend, that is what we did to compare against everyone.
Okay, thank you. Could you go to slide 41?
Yes. I just have to share it again, just a minute.
Sorry, I make you do boring things.
No, don't worry. Okay, slide
41.
41. Yes.
I'm sorry, but my heart skipped a bit when I saw that, because it is written tree, and so, okay, I'm understanding what is a tree, but this is not a tree that you are showing us. It does not respect the main properties of trees, which is you have to have a node as only one parent. And so what is happening here?
It happens that in pattern mining, we can have a fact, it can happen that we have a pattern that has several parents. So from different patterns, you can create a node that have different parents, in fact. So we use there is from MCTS the wave approach to unify such a node, because they are the same pattern, in fact.
But does that mean that, for example, when you go on the rightmost branch,
yes,
it may, so we see that one of the rightmost and second rightmost, they lead to the same. So does that mean that, okay, you do your select, and then you may fall again on the same pattern, so the exploration will, by several branches, go to the same pattern?
It could, in fact, in the exploration. From you say that I'm not
Yeah,
sure I understood correctly. If you are here, you can go here, and
yeah,
you can go here.
Exactly.
Yeah.
But okay, and they let you do that. We agree that this is heretic in pattern mining. We absolutely want to avoid using several ways to get to the same pattern, because then we are losing a lot of time in exploration.
Yes, but it is. I did that some months ago, so I would have to check on the code to make sure that. I think that we have a strategy saying that it does not create a node that is already existing. So if we arrive here and we arrive and we would create this node, the algorithm say, oh, it is already existing.
So you have a list of all the nodes created?
Yeah, and you have a list linked to...
So you have a list of all the patterns in the system?
Yeah.
So
in fact, yes. In fact, we have... I think the strategy is, if you create a pattern that is already existing, update the value of the parent nodes with the quality of this one, and just create a new one, because we do not want to create a pattern already existing.
Yeah, okay. But okay, I don't know if you have the choice with MCTS, but you don't have memory problems, because technically your list of patterns is exponential.
Indeed.
So you will die.
If indeed, if you plot the random access memory over time, it is linearly increasing, because indeed how to say that, the tree is growing exponentially, but we create them linearly over time. So as the number of nodes increase, your memory will be the memory taken will increase too. Yeah. So you need to take that into account. In our case, because we are dealing with in the case of sequences of item set, we performed way less iteration than on the classical case of transactions, because computing the support and the quality measure is a step that is much more costly to take to check if a subsequence of another one is it costs a lot more. So in experiments, even if we launched it during 1 or 2 hours, we did not meet problems with memory. But yeah, you have to take that into account. Indeed. It is a limit of the approach.
Okay, thank you. I'm done there.
Thank you for your question.
Welcome.
All right, so thank you, Alexandre. So now we are moving on to the examinator, and I'm going to ask Anne-Laurent, who is a professor at the University of Montpellier, to start.
Thank you. Thank you, Romain, for the document and for this talk. It was very, very clear as a document, actually. You did not mention a lot that it was in industrial with Atos company, so maybe it's a point something to point out, that it was particular context, and in this context, you both worked on this use case. Very interesting. I'm not a gamer, so I'm not very. It's not easy for me to imagine how this use case is relevant or even interesting. But I guess I'm pretty sure he is. Thank you for your supervisors for inviting me. I'm sorry not to be here with you because of this situation, but okay. So I have some maybe remarks and questions mixed. One of them, when I read your document, I was wondering why you did not point out more the literature about bandit models and classification, because there have been a lot of works on this in machine learning. I'm not an expert on this, but I saw this in the in the program from conferences and so on. So is it something you cannot do everything? So it's one of the explanations, I guess. But is it something else that it was useless, or I don't know?
Actually, the UCB is the most well-known approach, and the MCTS is well-known. So we try to apply a well-known approach. Now we have, for example, for the UCB, for the computing, there are other propositions. So first, I did not look a lot in the literature. So I don't know. I'm not gonna lie. I did not work a lot on this literature, but there are several contributions in the UCB formula. And in fact, what is interesting that the MCTS uses this UCB formula, which is called the UCT, the upper confidence tree, but it is an adaptation of the UCB. And several other upper confidence bound have been proposed to, in the work of Guillaume Bosque previously, they tried different UCB. To take into account the variance of the patterns sample or things like that. And in fact, from what I experimented, but very recently, there is work to be done on the UCB, because this is critical to go to interesting search spaces of the area of the search space. Because in fact, in the case of MCTS from game theory at the beginning, we want to go to situations where we tend to win. In the case of pattern mining, once we found a pattern that is interesting, we do not want to find it again because we already find it. So maybe maybe there is, I did not work on that, but trying other UCB specialized to the case of pattern mining would lead to better results and will be more interesting. And in the case of the proposed UCB, some of them are mathematically founded, like the UCB1 that guaranteed that asymptotically we bound the regret. But there are a lot of other propositions that are purely based on, that are not mathematically founded, but by intuition, and they work well. So I think there is work to perform on the select of this UCB. Here we only use the basic one. We focused on all the things, but these problems remains open, I think.
Okay. Still on this classification and the link with labeled data and supervised learning. What about the word causality that you are not using a lot in your document? You use it at the beginning for the state of the art in the introduction. I don't remember well, but then I guess it's difficult and maybe even more in sequences. But now that the work is done and you have these years behind you, how would you discuss this regarding discriminate patterns, regarding this REC measure and so on? What would you say about causality? And maybe I just add something. what about the link with causality? And Martin discussed this a little bit also, but description, prescription, but you know, time lags, time gaps, windows, sliding windows that you have learned, you have studied as well, and these links that time is running, causality can appear, we don't know where.
Yeah, so for the causality, indeed, I talked a bit about it in the introduction, because in fact, we are emitting hypotheses. We have data, we are not in a clinical process when we can have random control group, etc., to make sure there is no bias. In fact, we have data that are collected and they could be biased. We are proposing to mine hypotheses from the data that we then propose to the experts, and the experts needs to tell us. We are here to help the expert to boost its expertise in order to better know, and only he or her will tell us if this is true knowledge or not. Because in fact, in data we have we can have a paradox, Simpson paradox, we can have a big bias, so we cannot be sure if the rule that we extracted are real knowledge, are real causal. We really need someone to make further experiments and to tell us if it is the true knowledge or not. So this is the answer for me for the causality. Moreover, I know there is the very interesting work of Julia Spurs on causality that I did not have time to read enough, but I think I'm interested in that. In particular, I see that Mario Bolle and Riken posted a paper on this topic, so group discovery applied to causality, like some days ago on an archive as a preprint. I didn't have time to read it, but I think it is, in fact, it is a problem that I thought would be very interesting to take interest in for further research. For the question about the sequentiality of sequence and the gap between events and the constraints on the time between events for the pattern that we mine, I think we clearly need to apply this generic approach to other pattern language like chronicles or something else. I'm not aware of the pattern language that we have in the community, but the pattern language that we chose here indeed keep only the sequence of events. So we could add just a constraint of time between events, a constraint on the gap, or we could also choose a much more specialized, much more complex pattern language to deal with such a problem.
And what do you call, you use the word recognize. I'm not sure I understand what it means. Is it like prediction, anticipation in a way, or?
I don't remember when I used it.
It was, I'm not sure it was in the document, but in your presentation, it was slide 91, and in your use case, I think, if I remember well, and you are saying and telling us it's all about recognizing. What would it mean, recognizing this?
In fact, recognize in this case would be for commentators, for the human to recognize. In fact, it will be to.
But when?
To detect, yeah, to classify.
Before it happens, or when it happens, or
when it happens.
Okay, yeah.
We could try also to detect it before it happens, but if they are commentators, if they are analysts, they do not want to say there probably will be a skill shot. They want to say, oh, this is a skill shot, it has been performed, and comment it after the action has been performed, I think. But it may be of interest too to detect it after, in fact.
Okay, actually. It's like a pattern recognition. Okay, very clear. Maybe another question about because it's kind of a topic I like. How would you deal with imprecision? And I'm not sure I understood well what you mean by data augmentation and your figure 6.3 in your manuscript. And I'm not very sure if it's linked or not to the kind of dealing with imprecision and generalizing or something like this. Could you?
So what we call the data augmentation here is in fact data, it's merging data from two different sources. So contextual information from the replays and player inputs. We align them. That required a lot of work because there is the in-game with the timestamp and the timestamp that we had in our data collector. So it required a lot of work. So data augmentation is just that. And for the idea of this noise or fuzzy things, in fact, the pattern language that we choose with the idea of having intervals growing or removing objects, this in fact deals well with the noise problem, because in fact, if we look at the sequences of inputs, the players are not robots. They cannot perform the same figure 2 times. They can perform the same figure, but the combination of inputs pressed by the player will not be exactly the same with the same timing, because we are not robots. We are doing it with instinct, but even pro players have a lot of noise in their patterns, in the sequences they generate. And in fact, this approach, by removing and generalizing, creating generalization of behavioral patterns, deals quite good with this noise problem, because we classify with the good performances. Okay,
thank you. Maybe another two, but last questions, about small ones, because I'm not an expert on these questions. But there are like trends currently. One of them regarding parallel implementations, and especially on maybe sensitive data, which is not your use case, but it's about federated machine learning. And would your approach be a good candidate for federated pattern mining, meaning that you can split data sets or respect that they are separated and then mine separately?
So I'd say that yes, because in MCTS we have several ways of parallelizing the MCTS. For separating different data sets, we could just launch an MCTS on each of them. Another interesting parallel setting that we could use, I think it is called the leaf parallelization, if I'm not sure, but the idea is to launch a rollout, each rollout in parallel, or we could even launch MCTS full cycle in parallel with semaphore, with lock on, in order to wait for MCTS cycle or rollout to finish before launching another one, because we need to update the node in the tree. So actually, I did not work a lot on parallelization, but it's true there is possibilities with this kind of algorithm.
Without sharing data.
Yeah.
That's the point. Okay. And my last very small question is, because you were working with Atos.
Yes.
Okay. And they're working also on quantum computing. And some results are starting to come up. I saw a paper from Livara Levola on this, on quantum machine learning on this kind of models. Have you discussed this in the company, if it's not confidential?
Actually, I did not have the chance to discuss about it in the company yet. No. So I cannot. I cannot.
Kind of curiosity.
Yeah,
Thank you. Thank you.
Yeah, Atos is a big company with a lot of researchers in the whole world. I worked at the agence of Lyon. I encountered different experts, but not the one of the quantum computing.
Thank you. Thank you, Sian.
Merci, Anne. Thank you. So the next one is going to be Professor Germain Forestier from University of the Haute-Alsace. Germain.
Okay. Thank you, Madam President. So thank you for the presentation, and thanks to Jean-François and Mehdi for inviting me to be a member of your jury. So I agree with what have been said before. The manuscript is well written, and the presentation is a nice addition and well reflects the content of the thesis. So I've been a little bit frustrated, as you mentioned, the urban farming application in the introduction, and it looks very interesting, but it is not presented in the manuscript. But the gaming pattern, the behavior discovery is also very interesting. So I'm not an expert in pattern mining and bounding models. So chapter 2 and 3 were a very nice introduction and provided me everything I needed to understand the rest of the manuscript and your contributions. So let's move on to the questions. Some of them were actually asked by the other member of the jury. So let's focus on the other ones. Let's start with chapter 4. The first question is a very general question. So in your manuscript, you mentioned in the experiments that to the best of your knowledge, you are the first to address the problem of supervised discriminative rules discovery in sequences of item sets. And therefore, there are not available algorithms that can be used directly as baselines for evaluation. So I was wondering if you had any ideas on why nobody looked into this problem before.
Because this is, I have hypothesis. Well, my first hypothesis is that the pattern language is much more complex than with transactional data. In fact, for example, if you take the item set mining, you have a limit on the pattern language. In the case of sequences, you do not have limit. The limits are the object present in the database. So I think this would be a possibility. Another possibility is that we subgroup. Another possibility also. Another is that in real cases, there are many data sets that are transactional with numerical, categorical, or Boolean, where the sequentiality does not have importance. So the availability of data sets is, I think, important. One of the things, yes, for the interpretability, if we have very long patterns, in the case of sequences, we can have very, very long patterns. So it can be quite difficult to interpret them for non-experts. So for someone that is not, for example, in the case of DNA sequences, we can have very, very long sequences that is interesting, but for very specific use case and for experts. When you are dealing with transactional data, I'd say that you can have shorter patterns that are quite easier to interpret, I'd say, in general. And that may be the reason why people worked more on that. But it is a difficult question, actually.
Yeah, sorry. Just, yeah. No, your answer is very, very good. I mean, we don't know actually why people are not working on that. We can make hypotheses, and you'll see.
Yeah, my hypotheses are those.
Yeah, thank you. So you also mentioned that each algorithm has been launched five times, and the reported results are averaged over these runs. So I see the error bars on your plot. So I'm assuming it's the standard deviation over the runs.
Actually, it is not exactly a standard deviation. It is the 95% confidence interval.
Okay. So I did not see a discussion about the stability of the results over multiple runs. So maybe I missed it, or can you comment on that, the stability of the results?
Well, as we see, but yes, with these bars, in fact, I did not look a lot into that, but we thought that with these bars, this will give us an idea. Oh, I'm not sharing my screen. Wait, just a bit, please. Yes, with this 95% confidence interval, I think this gives us an idea of how what is the repartition of the results, because indeed there is randomness in our algorithm. So it is interesting to see that for here you can see I don't know if we can see very clearly, but the black bars represent also this 95% confidence interval. So generally, it is clearer here with the green Monte-Clopi. In fact, we quickly converge toward interesting patterns, but there are iterations. If we launch the algorithm again, we will find quite similar patterns. So the distribution is quite similar for the quality, but it is purely experimental. Okay, it is not. We do not have guarantee on that. Experimentally, it seems that it is quite centered around the mean. Contrary to MISER, which you can see is fully random. So depending on the launch of the algorithm, this will tend to increase the variability of results. And just to answer your first remark, I added here a backup slide if you are interested in urban farming. Just a word on that if you are interested.
Yeah, sure, go ahead.
In fact, we proposed an algorithm to mine what we call optimal subgroups. So the idea is we have urban farming where we have control environments with plants. So we control temperature, hygrometry, pH of the nutrient solution, etc. We control everything. And during the growth of the plant, we have to optimize the condition we give to them in order to optimize a target of interest. So in this case, we chose to only optimize the growth, so the mass of the vegetable that we get. But in fact, we are working actually on taking into account several measures. So the idea is the following. We proposed an iteration, what we call a virtuous cycle, where we grow. First, we grow vegetables with what we call recipes. So a setting for each growing condition. We make them grow. Then we get the data and we get the optimal subgroup. So for each value, for the temperature, for the hygrometry, for the pH, we look for the best interval pattern that tend to optimize the target measure. This will give us a restriction on each control growing condition, and then we will again define new recipes with the values randomly set inside those intervals that we mine, and we perform that full cycle again and again and again until getting the optimized recipe for the desire for the vegetable that we want to optimize. That is mainly the idea. I hope this was quite clear.
Yeah, thank you. Okay, so next question. So you mentioned that instead of giving a fixed time budget for running an algorithm on each dataset, you choose to limit the number of iterations. So I was wondering if the iterations are actually comparable from one algorithm to the other.
Yeah, this is a good remark. In fact, in the experiment, we did both. The number of iteration, because we realized that depending on the dataset, if you set the same amount of time, the number of iteration will greatly depend depending on the size of the dataset. So we perform the experiments with the time and with the iterations to make sure that we perform well and there is no bias with that. So yes, if we take into account only the time, it works in a similar way, yes.
Okay, thank you. Okay, so let's move on to chapter 5. So for the adaptation for time series of different length, you mentioned that you randomly remove intervals from the longest one to have two interval patterns of the same length.
Yes.
I was wondering how this step impact the results. Did you have a chance to evaluate that?
Well, it is a choice that we made to adapt the pattern language to be able to deal with time series of different lengths. When we did that, I cannot remember if we found something else to compare against. So actually, we have the result compared to dataset with the same length to have an idea of how good it performed, but we would have to dig deeper in the literature to compare against other approaches to make sure, because actually we did not know.
Okay, thank you. So for the experiments, you selected around 10 datasets from the UCR archive, which contains more than 100 datasets. So I was wondering, how did you pick them up?
Quite randomly, actually. I tried to make good distributions of lengths of datasets in order to have a better idea. I also looked for multivariate datasets because there are a lot of work on classification. From what I see, I'm not an expert of time series, but from what I saw, there is a lot of work on univariate time series, and now we could deal with multivariate. So it was kind of interesting to show that.
Mm-hmm.
Yeah.
And the next question is linked because these datasets comes with a split of train and test. Yes. That is done directly in the archive. So I was wondering, how did you use these two sets in your experiments?
I think I worked only.
So it's frozen on my side. I don't know if.
Yeah, same here.
Okay.
Okay, so
I extracted the pattern only from the training set and experimented. That is fine.
Yeah, it's
now?
back. It's back now.
Yeah, you're back.
Okay, sorry, we have in 4G, so they make some issues. So the question was
about the train and test split. How did you use them in your experiments?
I think I would have to check it in the code, but I think that I used only the training to extract interesting patterns because we had some experiment then where we try to use them to classify. Mm-hmm. So we will not train on the reunion of the train and the test. We extract the pattern only on the training, and then we classify in the classical way with the test. Yes.
Okay.
So
thank you.
the pattern are only from the training test.
So the next one is more a comment than a question. So I know that your method is not presented as a time series classification method and that you do not claim to have state-of-the-art results, but I think that you have been a bit unfair on DTW, saying that it takes hours to run, because I think that you probably spent a lot of time trying to optimize your approach. You mentioned, for example, grid search, but on the contrary, I think that you use the vanilla DTW, while there exist also many ways of improving its execution time, like using a warping window or using lower bounds too. So again, it's just a comment. I don't know if you want to react about that.
Yes,
or...
yes, but you are perfectly right. I realized that like 2 or 3 months ago when I saw a presentation of Iman Keogh about time series, and I discovered things that I did not know at the time, like these warping things to optimize it, because it's a quite naive implementation, in fact, that we have. So we could, it is true that we could increase the performance on the DTW. Yeah. Yes.
Okay, thanks. But it's already good that you pick up something to compare to. So in your setup, you mentioned that you use random forest classifier of 100 trees on the re-encoded datasets to evaluate the performance. So I was wondering if you also performed the same experiment on the raw data to check the added value of the re-encoding.
If we trade the same with the real data? No.
Yeah, the raw data, because you have this step of re-encoding, and then on the patterns you apply a random forest classifier with 100 trees. So yes. I was wondering if it was possible to apply directly the random forest with the 100 trees directly on the raw data, so that we can check the added value of the re-encoding.
Good question. In fact, from random forest actually deals with transactional data. So with numericals, Boolean, categorical Boolean and numerical data. And in fact, this dataset is sequences or of potentially varying length. So we could not feed it to a random forest. So we have a choice here. Either we use specialized algorithm for classifications of such data, which are sequences, in fact, or we can make some feature engineering to compute some feature from the dataset and use these features to classify this object. That is the project that we did with Mehdi at the end of our study, actually, with the StarCraft Traces, another video game where we extracted features like the n-grams, things like that, and we applied algorithm on that. So I think that applying such an approach to this case would require to make some feature engineering that is depending on the case we're dealing with. So the answer is no, we did not, but we were not sure it was interesting because it depends on the use case and we want to be generic.
Okay, thank you. So let's move on to chapter 6. So I had the same question than Anne about data augmentation, so I'm going to skip this one. So you mentioned that you filter redundant patterns following the Jacquard index using your parameter theta. Mm-hmm. So I was wondering how many patterns are filtered out, and will it be possible to somehow detect that redundancy during the search?
Well, it depends. We have a threshold on the redundancy between 0 and 1, depending on how non-redundant you want your patterns to be. So depending on this, you can filter all or nothing. So it depends on the setting. And the second question is, during the search, can we take...
Yeah, is it possible to detect the redundancy during the search to avoid doing it as a post-processing step?
I think, well, in fact, it would be quite easy to perform it when you are performing a top 1 element because you have only one element you want to compare to. But when you are performing the top K, this becomes a NP-complete problem. And this will require a lot of computing and it will be less efficient, in fact.
Okay. Thank you. So you mentioned that Rocket League seems to use an in-game system using ad hoc rules. So I'm just wondering if you try to contact them to have some information about their system of rules? Or...
Actually, I did not try to contact them. In fact, Psionics seems to be listening to the community, but take some time to answer to them, to the request and a particular game creator or content creator. So I did not try. I am not known I am not a famous full YouTuber with millions of views. So I did not. I did not try it actually.
Okay, no problem. Okay, so I still have 2 very short questions about the conclusion. So in the conclusion, you mentioned making algorithm exhaustive on all cases. Mm-hmm. So I was wondering if you had ideas on how to do that.
Yes, well, it is quite complex in the case of sequences of item sets because what we would call the meat that is not unique in this case, so the LCS, the longest common subsequence between sequence of item set is not unique. And to be exhaustive, you would have to compute all the longest common subsequence, which can be which can take a lot of time. So another approach that I realized recently will be, in fact, to transform sequences of item sets into numerical data. You can do that too. In fact, for each item set, you can take all the items of the data set and set its value to 1 or 0. So you will have a big sequence of all item set possible for each timestamp, for each item set. And you could apply Monte-Clopy. So you would have a high dimensional numerical data. And on this case, you will be exhaustive on the close and the positive even. But the size could be quite large. So.
Okay, thank you. And the last question, so you also mentioned parallelization in the conclusion. So Anne asked a question about it. So I was wondering if you could also use GPUs, which are very trendy these days. So did you see any work using GPUs for sequential pattern mining?
To be honest, I do not have enough expertise to not say anything wrong with that. I guess that yes, I see that a lot of people are using GPU, in particular for deep learning. that will require further research.
Yeah, but apart from deep learning, maybe I don't know if the problem can be cast into something that could be run on GPUs.
Maybe, actually, yeah, maybe.
Okay. So thank you. This is it for me. So thank you for your great answers and congratulations. So I know that defending a PhD remotely is not easy. So congrats again and thank you.
Thank you. Thanks a lot.
Thank you, Germain. And now the best for last, I guess, the domain expert from Ubisoft, Shedi Raisi, who is also a researcher at INRIA. Shedi.
Thank you. Yes. So first of all, thanks for inviting me, in fact, to participate at the PhD defense jury. It was very interesting. As everyone said before, I really appreciated reading the manuscript. It contained, you know, some fresh views, in fact, on the current research that you have for pattern mining, and very interesting ideas indeed. So before switching to the usual Q&A section, and I have a curse because I'm probably the last one to answer. The question is like all the interesting questions have already been answered. So I have to almost like on the fly get some of them anyway. So I just wanted to highlight again the fact that—
tell us about games. I mean, that's why I left you for last.
Oh, okay. Thank you very much for this one. I tried to avoid talking about games, but we'll try to get there. Anyway, yeah, I wanted just to highlight again the quality of this manuscript. It was, I mean, for me, it was a delighting moment to read it. It had really nice supporting illustrations, and the fact that you had pseudocodes and even pushing it to the, you know, the reproducible science aspect by having some of your work on GitHub was really interesting. And some of the engineers here at Ubisoft, thank you for this one. So yeah, let's get now to the questions. And again, I have to say that these are more of like remarks and open questions than just trying to, you know, like shed light on some flaws or some bad ideas. Let's start with chapter 4, and this was already discussed with Alexandre. Chapter 4, page 43. Yeah, let me put also the video here. Yeah, so you decided to use a uniform distribution, in fact, for the removal of the items. Alexandre talked a little bit about this. And I was wondering why not condition on the frequency of the items, as this is going to be a cheap approach to get. Right now, you're using a uniform, of course. And my question was like, if you know that some of the items are more frequent than others, you can condition on the removal and have like guarantees on the support that you will get. And you can even compute maybe some upper bounds or lower bounds on the support on this one.
Yeah, actually, this is a very good point. Just like in the previous answer for Martinez Müller, I said that we could use a heuristic to select the next object to add to the pattern currently to create a better pattern. We could also use heuristic instead of these random things for the rollout step in order to increase the results. Yes, I think that could be only interesting. This actually we chose only the simplest one, which with quite good results, but further research would be interesting in this direction. It's not certain, yes.
Okay, and just to get a little bit more into the details of this, I was wondering also if you thought about using also not just the removal of an item, but the removal of an entire item set. So for instance, like suppose you have A, B, C, D, and E, and a second item set to be F, G, and a third item set with whatever. And you could, I mean, if you're able to have an estimation of, let's say, the support basically on G and H, or like 2 items, you could remove one of these item sets directly, right? Why just try to remove one at a step, let's call it like this?
Yeah, we could try it. I'm not sure. I can't recall. I can't remember if I tried it. What I know is that in the toss a coins step, there is cases where we remove all items of an item set, so the item set gets out. But removing the whole item set could be an interesting thing to check if you will go upper in the search page. So yeah, it may be of interest to try that.
Okay, still in the same chapter. This one is on page 49, which is about the counting and enumerating, and this is related to the longest common subsequence. You were in fact citing Elias Hérault, who was at one moment my PhD student in Nancy. And you were talking about this idea of like, you know, the fact that in one of the papers that you were citing, we were just counting, in fact, the number of longest common subsequence. And my question was on this one, you showed that you had a dynamic programming approach to extract the LCS. My question is, can you use the counting that we had to have a bound on the DP algorithm that you had?
Actually, I looked in the paper in the first place. I did a lot of research because you know that there are works on longest common subsequence between sequences of items, but between sequences of items it's a problem. So I read this paper, which is very mathematic and quite difficult to understand actually. But from what I understood, here we compute the number of possible subsequence of possible longest common subsequence, but we do not have the procedure to generate them. So that is why we propose this dynamic programming. At least maybe there is, but I could not see it in the paper. Now, toward the bounding of this, it may be actually, it would require further research too. Yeah.
Okay. In fact, I think I'm not 100% sure that we can get some bounds out of it. Basically, at the end of the paper, we had an approximation method that was also based on what some other persons did a few years ago. Okay. And this could be used. I'm putting again a conditional on this one. I'm not 100% sure. And it's easy to say this when you're on the jury defense, especially if it's remote and you're just sitting on your chair. But it could be really super interesting to try to see if this could speed up a little bit. Again, it's dynamic programming, so you don't have like this crazy complexities to beat anyway. But it could be interesting, especially for very long sequences.
Yes, because we are only computing one longest common subsequence, one possible. And if we want, in fact, the GP, when you make the the backtracking procedure, you could compute all possible longest common subsequence, and any idea that could speed up this process would lead us to maybe an exhaustive algorithm for this case. So yes, that would be of interest.
Yeah, so this was one of the questions that, well, okay. I had a question about the fact that if you were backtracking basically on your roles, would that be enough of an answer to have at least let's say some kind of a memorization of the values that you have on the longest common subsequence. So I guess you already thought about this.
I think that yes, but that needs to be proven. We need to prove it to be very sure.
Yeah, I mean, I was thinking that this is the kind of optimization you could be doing to get even faster runtimes for your algorithm. Yeah. Now, another question, this one I know is linked also to some of the work that we did with Mehdi. It's about, in section 4.4.6, you're talking about multiple quality measures. And when I read this, usually in page 54 in your manuscript, I was thinking about the Pareto front. So my question here is like, how would I be able to select using, for instance, Monte Carlo tree search? How will I be able to mine or select some patterns that will be good on multiple measures at the same time, or at least where I could explain why one of them is better than the other? Yeah. And is this still possible in the MCTS approaches?
Actually, we are actually working on that in the case of urban farming with another PhD student here that is called Alexandre Millot, because we want to optimize not only one target label, but several. For example, for plant growth, we want to optimize the mass of it, but the energy it costs and the nutritive value of or chemical values or things. We have multiple targets that we want to optimize. Yes, we need to compute so in this case, we are optimizing multiple targets, and your question is with multiple measures, multiple quality measures or multiple targets?
No, multiple measures. So basically, if I have, let's say, a set of measures M1 to MK, and I wanted to say choose the best let's say, choose the best patterns that will maximize the measure on M1, M2, M3, and for instance, it will minimize this one on M4, M5 to up to MK. Did you think about it? Do you know about the literature around this kind of, pattern mining?
I would say that in pattern mining, not a lot, but I would say that indeed it would be interesting to compute the Pareto front in order to identify the best elements that are not dominated among other dimensions. And yes, that could be of just computing the Pareto fronts to give the set of interesting patterns with the interesting point on the Pareto fronts would be of interest, I guess. At my first idea would be to compute that. Yes.
And would that be exhaustive enough for the patterns? Like at the end of the day, you're sampling some of the patterns, right? So how would you merge both of these ideas? This is just an open question because.
Yes, that is a difficult question. That is an interesting and difficult question. Could we be exhaustive on that? It is much more, if we consider that the exhaustivity is to compute the Pareto front for each pattern, we could be exhaustive on that. Yes, I'd say. Now it depends on your definition of exhaustivity. Maybe depending on your use case, you do not want to compute the whole Pareto front. Depending on the number of dimensions, maybe sometimes it is the Pareto fronts will represent too much patterns and you only want to have fewer of them. So you have to, I think there is a trade-off to find between the number of elements on the Pareto front depending on the number of dimensions and the number of patterns you want to give to the end user.
Okay.
From what
it's good enough for me for the moment. No worries. Now to chapter 5, a lot of questions have been asked about this chapter, so I'm remaining with a few of them. One of them is about the comparison when you were talking about the baselines and you're not really comparing with deep learning. And I thought, in fact, Germain was going to jump on and ask all the nice questions because I think he has a set of interesting papers. One of them is even called, I think, transfer learning for time series classification. So I was wondering why not even like trying it, because right now, like some of these implementations, most of it is like simply cloning the GitHub repo, changing the data so that it works as an input data and just trying it. So is it more of like you didn't really want to, or you already knew that you were far away from the state of the art?
Well, our goal at the beginning was to be interpretable. So to find interpretable pattern that we can give to the end user. And then we extracted them in order to classify. But the first goal was not to classify. So we did not compare against because of that. Also because in our use case, because this work has been motivated by this use case, we did not have a lot of sequences. So we thought that deep learning would have issue with that. However, I'm not an expert enough on deep learning to be sure. There may be some approaches that work with fewer sequences that could be of interest to compare against, indeed. But I was not aware of it at the time I wrote this.
So yeah, I mean, this question, or like, let's say this discussion about the volume of data that you need to get for deep learning sometimes can be a little bit misleading. You could be training, for instance, you do what we call some transfer learning. So basically you already have few of the architectures and some of the models that have already been trained either on the same problem or a very close problem to it, and then try to just fine tune some of your model by training over 300 or 400 sequences. And I guess you could get something out of it. Yeah, another thing is about the interpretability. So let me ask you this question. What if you just use a neural network? I don't know, let's say 1D convolution or some attention-based models that you have right now that are working very well on speech, for instance, classification problems that you can also see as a multivariate time series classification problem, or even satellite images, whatever. And after that, instead of going the way that you did with pattern mining over the traces, why not do some pattern mining, for instance, on the weights or that you have inside the neural network, or for instance, also on some of the embeddings that you have on the neural networks. And that would be also some kind of an explanation that you could get, right?
Yeah, you would you would use pattern mining in order to explain the results of your black box model, in fact.
Yeah, for instance, it could be something where you're saying, okay, why not? I could just mine, for instance, the different filters activations that they have, yeah. You know, over it, and I can see it as a sequence also, and that could be also something that would be of interest. And
yeah, that could be.
It contains, I guess, probably some problems that I'm probably overseeing right now. But I was wondering about it when you were talking about the interpretability a few minutes ago. Yeah. Let me switch to the different other questions. I still have a few of them. One of them was about the parallelization on MCTS-based approach, but this one got already answered to some extent. And now let me get to the video games part. So hi, Sihan. So in terms of the skill shots over your Rocket League game, my question here is, how do you label the skill shots?
Because first we identify the skills that we wanted to perform. And actually, I played the game in a free play mode, so without opponent. And I just say, okay, now I'm going to perform a lot of skill shots. I perform a lot of them. Then I watch the replay and I label them if they are performed correctly or not. And depending on what skill shot I see is as being performed. So I take the replay, I cut the beginning of what I judge is the beginning of the skill shot. The end is often the goal, if we put the ball inside the opponent goal. I cut this, I merge this with the input players, and that creates our labeled dataset.
Okay, so I have a question for you, and this one is more of the industrial aspect here and the video gaming aspect here. So just before we started the thesis, I was just taking a look at some of the data that you have for Ubisoft, one of the games that you have right now, which is Assassin's Creed. And I was taking a look at the latest Assassin's Creed people that are playing right now. It's and currently right now at the time when we started around 3 p.m. there was like 7 million people playing. Do you think it's feasible to do this kind of labeling? Let me imagine, for instance, that we have a notion of skills or skill shots or whatever, like killing actions that you can get in that game. Do you think it's feasible to try to label part of it?
I think it is, of course, it is impossible to label the 7 millions, but you can try to extract a subset of it, a representative subset of it. So you need experts which know the domain enough, and then try to label as much as you can, and then create your classifier and try it in real case and depending on if it overfits or not, if it has a big bias or not, maybe label depending on this, maybe it will be of interest of labeling order to augment your data set, I'd say. Another possibility is to automate the automatic labeling. So for example, if in Rocket League, you can automatically extract all sequences that finished with a goal. So here we have the automatic labeling. We do not have to have human labeling sequences. So,
but how far do you have to get back for the automatic labeling? So if I understand correctly, you're saying that on one side of the events you have an end. What you're saying is that you have an end position.
Yes.
And now how far do I have to get back to start the capture and start learning?
Yes, this is a problem that I did not first think of when proposing this idea. How far do you think to go back? A possibility would be to first compute some example representative by a label expert and to compute the mean when there is something. the distribution of time you need to take before the event, and maybe use that to automatically extract automatically interesting things. That may be an approach quite simple that could give interesting results, I'd say.
Okay. And this one is more of like, again, a remark and an open question. Did you hear maybe about active learning? So I was wondering, or even self-supervised learning that you have, would that be of interest in that case? Where, for instance, I could start with just a very small sample of labeled positively and negatively, or whatever kind of class you can imagine. And imagine that you have an extraction or a modeling part where it's able to tell you which unlabeled sessions or moves it's not sure about its classification, and give you back the command so that you can label it. And in that case, maybe limit and kind of have some self-automated to an automated aspect of, pattern extraction here.
Yeah, I read 1 or 2 papers quite recently about it, and I think it definitely could be used in this case.
Is it papers that were done on like active learning for pattern mining, or so it's merging both ideas?
Yeah, actually it is a review that I made for ECML PKDD, but the paper did not get accepted, so I cannot refer to it, but the idea was exactly that.
Okay.
With a different pattern mining approach, of course, but yeah.
Okay, and just one simple question again related to Rocket League in that case. What's the domain, the cardinality of your items?
The number of buttons the player can press, or the range of the value for...
So the number of buttons plus, let's say the number of buttons plus the extra information that you get, plus the context.
Yes, so wait a bit,
I mean, is it like less than 100 or?
Yes, it is less than 100. I think it is at the end, a bit less, or around the 100. Let's see, wait. Here we have 11 inputs for the button pressed, and we selected 7 variables, numerical variables, so contextual variables, and inputs are player inputs. So we have like around 20 different variables in this case for each state. So we have a sequence of state, and on each state you have that number of variables. So the sequence, if you compute the number of variable in the whole number of value in the whole sequences, it was like something like of the order of several hundreds values.
Okay. And continuing on this one, because this is quite related to it, and this is something also that we had to discuss here when we are modeling some of our ideas, and when we're modeling what people are playing and how they play. How do you basically discretize the continuous aspect that you have on the gamepad? So for instance, if he's like pressing on the right, if he's pressing the right button on the gamepad, do you take like how long he has been pressing on it, or is he like doing it?
I'm doing exactly as it is described as with this figure. So it was quite difficult to explain. So I did this figure exactly for this question, in fact. So if you have the button A and the button B that you press, you can see that in first time we press the button A. So we have the button A, then we press the button B. They are both pressed simultaneously. So we have the item set A, then AB, then I release A. So we have only B that is pressed. Then we pressed again A, so we have AB, we released B, we have A, etc. Is it quite clear for you?
Yeah. And another, like continuing on this one, do you also take, for instance, how strong do you press on the button?
I did not consider it.
So for instance, in our games, we, okay, how can I say it without breaking maybe like tens of NDA stuff around here? Let's say it like this. In some of the data that we process, we may have some of the, how strong do you press on the buttons? Mm-hmm. And this is a very good, a very good information to know how skilled the player is. Usually when someone is starting to play the game, you can have, you have a different way of touching the gamepad. And we even have a way of like sometimes be able to classify between gender and ages. So for instance, kids have a different way of pressing the buttons. Let's say a class of age has a different way of pressing buttons with respect to older persons and stuff like this. So would that be of interest in your case for the skill shot? Because I know that, for instance, in some of the skill shots, you don't have to press the acceleration to the, to the maximum of things, like trigger on R2 or R1 and things like that. Is that an interesting thing for your modeling, or is it like just too much?
I think in the case of Rocket League, in fact, players are a bit nervous, and they tend to, it is a very nervous gameplay, okay? So you tend to press really quite strongly, I'd say, on the button. On one exception, with the jump button, depending on how strong you press it, you can make a small jump or a big jump. So there is indeed this exception where this could be of interest. For the acceleration, actually, the player, when I play and when a lot of players play, they have their
pressing the acceleration all the time, right? So why do you keep it as an item? That was my final question.
In fact,
okay.
Because
but in the
70% of the time it was pressed, so it was non-informative. We removed it. Yeah. Okay. But we could do as you proposed, and we could do just for the case of Rocket League. I'm not sure it would be of interest, but if you are interested in doing it in other use case, it would be quite easy to. In fact, it would just be a numerical value, so you could set it as an interval, just like the other contextual information has been dealt with.
Okay. Yeah, two final remarks, if you allow me. It's going to be very quick. One of them, while I was reading, and this is also some of the work I'm trying to push and still trying to work on. We talk a lot about UCB, of course, when we're talking about MCTS. And I was wondering if you try to take a look at some other alternatives, for instance, like Thompson sampling or other things like that, that will allow you to hook up your work maybe into more recent work, for instance, about Bayesian regret minimization and other things like that. So I know I've been like exchanging a little bit with Mehdi at one time. I'm not sure if you tried work on this kind of thing, but that would be interesting, especially earlier you were also discussing about the mathematical foundations that you can get out of the UCT/UCB approaches. The final remark is about causality, and this one is in page 7 with the reference to Udea Pearl paper book, sorry. And it's funny because he had a, well, if you were looking at the Twitter account of Udea this morning, he's having a very long thread with Max Welling from Amsterdam, University of Amsterdam, where they're exchanging rather strong opinions about what he called the radical empirism of deep learning and approaches like this. So he's trying to get us out of, snapping out of the data-centric paradigm that we're trying to push. So it's, I would say it's a complicated matter. It's a complicated part. I would have appreciated if I have seen it maybe outside of the introduction, even in the conclusion, maybe to extend a little bit about it. And yeah, it leaves us still with a lot of things to work on in terms of pattern mining and causality. And thank you very much. Thank you, Sihem, for allowing me this long time to exchange and discuss with Romain. Thank you, Romain.
Thank you for your questions and your attention.
Thank you. Thank you all. Thank you to the committee members. So I think now we're left with the supervisors, Jean-François Boulico and Mehdi Kaitou, and you can go in any order you wish.
I'm passing the mic. Just a second.
So I take this opportunity first to thank you, of course, all of you to be here today, here physically or remotely. I'm a bit sad that I cannot see you. If you are, I can see you on the screen, but that's all. I'm a bit sad about that. But still, I'm very happy to have been able to gather you for this PhD defense. So I do not have really questions because it could have been the last questions, the last time I would be borrowing with you, but the fact is that Romain is joining our company after his PhD, so I still have time to bother you after. So maybe I can not bother you now because I will still bother you. I would like to emphasize the fact that we've seen with you a very nice evolution for the very beginning of your PhD preparation and now. So I won't go into details on that. It's a story between Jean-François, myself, and you. But we've seen a very nice evolution and the results you were finally able to get, and your implication was really makes that I really had the pleasure working with you. So I want to say that especially. So I have some questions, but I do not dare because they are a bit tricky, and I will keep them for just after. I may just say one thing for Alexandre about the canonicity stuff, the exploration. Actually, we we did it with Shedi and Guillaume in the first paper. We showed that we can explore the tree as we did in pattern mining, like do not visit a pattern several times. But when you do that, you introduce a bias. We corrected that bias by correcting the UCB. And actually, we showed that it was not working better. It was even working in a poorer way. And the thing is that behind this MCTS, there is this rollout thing that is very important. You have to let it go everywhere because of the UCB stuff. And this is something we had some difficulties with it at the beginning, with Guillaume as well, with you as well, because there is always this temptation to drive the MCTS, because we know that if we tune the things a little bit, it should go to some good places. But actually, the magic is within the formula, and this is at the step of the formula that there is something to do. And I appreciate that you, because I did not emphasize it a lot with you, but you answer well the questions about that fact that the key point now is you worked a lot on the language aspect, so on sequences of item sets, but the key point that you did not deal with a lot, and that is somehow an open question, is to specifically work on that exploration exploitation trade-off. So I will stop there for my, let's say, questions, and thank you again.
Okay, so I think that anytime when I want to be kind, it's better that I switch to my native language. So I'm sorry, Martin, but I will say a couple of sentences in French. Je voudrais aller un petit peu plus précisément dans ce qu'a évoqué Mehdi. Romain, je t'ai connu quand tu étais étudiant en école d'ingénieur. J'ai eu l'occasion de te suivre pendant ton projet de fin d'études d'ingénieur, puis de voir que tu étais partant pour faire une thèse. Je dois dire qu'au départ, parce qu'il n'y a rien de caché en fait, tu avais toutes les caractéristiques d'un très bon ingénieur. Et tu n'avais pas forcément les caractéristiques d'un futur chercheur. Et j'ai eu le privilège avec Mehdi de te voir te transformer mois après mois et devenir pour moi un très bon chercheur, avec de très bonnes réactions, des bonnes méthodes de travail. Donc c'est une métamorphose qui est, enfin c'est toujours un plaisir que d'assister à ça, et donc c'est un cadeau pour le directeur de thèse que je suis. Donc, merci pour ça. Et now I can be back to English, but not to ask questions. Just to say that finally, it's the third PhD I had with Mehdi, where it combines the interest for games. So I never played any video game. So it is not at all my ideas that we can do interesting things with games. And now I'm fully convinced. And also heuristic algorithms. I've been working more than 20 years on exhaustive and complete algorithms. So Mehdi has managed to convince me that there were so many interesting things. And actually this PhD for me is also an example where we have a nice area to investigate. And probably, as I noticed during a seminar, probably with yet rather naive view on what researchers in artificial intelligence and games have been doing. So, I mean, I think that our point of view on MCTS remains rather naive compared with what experts in games, at least I'm talking for me. Maybe you are aware of more. But so it's a very interesting for the perspectives of that kind of research. So that's it. Thank you.
Thanks a lot.
Thank you, Jean-François. So as president of this committee, I have the luxury of not having to ask any questions, but I'm itching for one. I guess I also have the luxury of asking kind of a somewhat irrelevant question, so it doesn't really matter. So I kept thinking, that your system, is able to distinguish different types of players, obviously this is what you're doing. And so I kept thinking, me, again, not being a player, I'd like to learn, to play. So I wondered, what would be the simplest way you could use your system to teach me to play, either as I'm playing or even before I start playing, a sequence of actions that could be useful to me, so that I don't feel totally, I guess, stupid playing a game.
Okay, so I think it's an interesting way, the simplest one as I see it, would be to first show an example of the feature that you want to perform in free play. So first, the engine shows you what it looks like usually. Then it says, okay, try to do it. So you try to do it, and then the classifier will take into account your player inputs, and it will classify if you success or not. If you are learning, of course, you will not succeed at first try, but we could take the pattern of inputs, the desired pattern of inputs, the most discriminative, and see at which point in the sequence you fail, at which point it will say to you like, oh, there you accelerate, you are now on the ground, and you pressed the boost button, but now you need to press the jump button.
Okay, so that sounds like a reasonable strategy. You watch me play and then you react to it. But how would that help you traverse your gigantic space of patterns and?
Well, I'd say that you need to compute the most discriminative pattern of a screenshot and take that as the reference pattern to explain to the player that want to perform this screenshot. So I think that would be the simplest approach. Yes.
All right. Good enough to me, So I think we're done. So I guess we need to hang up here and meet on the other one, right?
Yes. So you just give us 2 minutes to join the office where we will connect. We let that room. Okay.
Okay. Okay. See you in 2 minutes.
See you.
Leave.
Puis après, c'est vrai qu'il faut revenir.
Franchement, il a fait pas mal de charges sur mécanique, mais le très facile. Je sais pas si c'est ce que je veux faire.
C'est intéressant.
Super.
Ça commence très bien.
Ouais. Je fais ça, moi.
Ça faut voir. Après, faut que tu gardes le bon contact. Si jamais tu fais ça. Du coup, bonjour à vous. Ça va? C'est enfer, je suis arrivé, mes concours de trucs, alors je suis parti, mais j'étais vraiment bien. Je suis parti à 9h. J'ai décompté 15 minutes dans mon garage par un mec qui n'avait pas bougé sa voiture. Il était garé, mais genre devant mon. Il n'était pas là. Il était pas là.
Mais du coup, t'as
laissé
ça sert à quoi?
Il avait
C'est la voiture.
C'est la voiture, elle était un peu contre-main, je pense. Je ne savais pas essayer de galère. Et du coup, je suis garé devant la BNC.
Mais pour se garer, non, c'était un peu chaud. On est arrivé par derrière parce qu'on pensait bien qu'en arrivant devant, ça allait être un peu. Mais c'est aussi avec les travaux et tout. On est garé
après la salle télé, parce que je suis garé comme une demi-heure au niveau de la BNC.
On a hésité, mais c'est pas venu sur le temps. J'ai le temps d'aller. Je pense que ça va prendre moins de temps. Hein? Oui, parce qu'un peu, les extrêmes va m'attendre aussi. Bah, si ça dure 10 minutes, on reste, mais si ça dure plus long. Bah, va peut-être pas leur temps d'y arriver.
Un peu de ça, mais la bonne.
Et après, à chaque fois, c'est tellement précis finalement que, en fait, même quand j'ai du domaine, c'est pas forcément que. Mais les conférences, c'est pareil en fait. Parfois, j'écoute, tu vois, au début, la motivation, ça tu comprends encore, mais après, quand tu deviens vraiment. Parce que déjà, quand tu me parles de l'état de l'art, tu vois, bravo!
T'es solide, mon gars. J'ai essayé une partie de ma santé.
Parce que j'ai froid par contre.
Il super.
Ouais.
Ils écoutent toujours les gens, là?
Ouais, c'est en ligne.
Juste...
Oui, mais c'est sur les gens qui.
Salut Johan et Aurélie.
Je vais couper le micro.
Et il y a ta famille ici?
Oui, oui.
Bonjour la famille de Romain.
Il n'y a que notre chat qui regarde pas. Il est là.
Oh, ah, oui.
Ouais, c'est CM qui va. Parce que oui, parce qu'elle ne sait pas qu'on est arrivé.
Ok, donc on est tous là. Bien, Romain, le jury a trouvé que tu as fait une présentation très claire de ton travail de thèse en choisissant de mettre en avant de façon pédagogique et pertinente les parties les plus importantes de ton travail, que tu as exposé un travail original sur une thématique d'actualité, la fouille de sous-groupes sur les données séquentielles et temporelles, en proposant des adaptations de modèles de Bandit Manchot et de la méthode de recherche Monte-Carlo. Que tes contributions font écho aux besoins en analyse de données et sciences et données de l'industrie des jeux vidéo. Nous avons également trouvé que tu as répondu de façon très convaincante aux nombreuses questions du jury, ce qui révèle ta grande maîtrise des aspects théoriques et pratiques de ton sujet, et que tu as une grande compréhension des algorithmes de fouille de sous-groupes et une grande curiosité intellectuelle. Le jury voudrait également souligner la pertinence de ton travail et son large spectre d'application de la fouille de données et plus généralement de la science des données, que tu as su développer une analyse rigoureuse des paramètres, différents paramètres de tes stratégies et que tu les as testés sur différents jeux de données. Et le jury a particulièrement apprécié l'effort que tu as mis dans la mise à disposition d'algorithmes et de jeux de données à la communauté de recherche, sachant le travail conséquent que cela nécessite, en particulier en préparation de données. Enfin, le jury est parfaitement convaincu que tu as acquis de très bonnes connaissances en sciences des données et que tu as tous les atouts pour continuer une brillante carrière dans la recherche ou ailleurs. Et pour toutes ces raisons, le jury, à l'unanimité, te déclare digne du grade de docteur de l'Université de Lyon dans la spécialité informatique. Bravo!
Merci beaucoup. Donc, c'est là qu'il faut dire quelques mots. Alors, j'en ai écrit quelques-uns hier soir.
On t'entend mal, on t'entend mal.
Je disais, j'ai réalisé hier soir qu'il fallait que je dise quelques mots. Alors, j'ai essayé d'écrire quelques trucs pour pas oublier, essayer de ne pas oublier. So first, I'd like to thank Mr. Martinez Müller and Alexandre Termier for accepting to be my reviewers. And I thank them for their time to expertise my work. So thank you for that and for your question and interesting discussions. I will now switch to French because it is easier for me. Excuse me for that, Martin. Je voudrais remercier les autres membres du jury, Madame Ameria, Monsieur Forestier, Madame Laurent et Monsieur Récy, pour avoir accepté de faire partie de mon jury en tant qu'examinateur, Madame Ameria d'avoir été la présidente, et pour la lecture de mon travail et de votre appréciation, vos questions et vos conseils qui ont mené à des discussions très intéressantes. Je remercie l'entreprise Atos avec qui j'ai fait cette thèse, qui a financé cette thèse, en particulier Christophe Boulard, qui doit être en ligne. Donc, coucou Christophe, qui m'a encadré du côté industriel. Donc, merci pour ta gentillesse et ces 3 années. Au niveau de l'encadrement scientifique, je vais commencer par Jean-François, qui a eu plein de gentils mots. Donc, merci pour ça. Merci Jean-François d'avoir accepté de prendre un jeune un peu taquin et un peu, pardon pour l'expression, tête de mule. Merci pour ça, mais je pense que c'est une des raisons pour laquelle on s'est bien entendu. Donc merci. Merci de m'avoir fait confiance et partager tes expériences afin de me guider dans cette expérience si particulière qui est la thèse, parce que c'est vrai que c'est quand même un moment particulier où on apprend beaucoup de choses. Donc, et de manière plus générale, merci pour ta bienveillance, ta franchise, ta sensibilité et ton soutien. Pour Mehdi, qui a été mon second encadrant, je te remercie pour ton encadrement scientifique pointu qui m'a sorti de la panade plusieurs fois. Merci pour m'apporter une autre vision qui m'a permis une certaine prise de recul vis-à-vis de la science en général et de mon travail. Merci aussi pour ta confiance et ta considération à mon égard, afin notamment de me laisser arbitrer mes propres choix. Je trouve que c'était quelque chose de très précieux. Ce n'est pas quelque chose que tout le monde fait. Donc, merci pour ça. Et puis enfin, merci de m'avoir trouvé une nouvelle aventure. On va continuer de travailler ensemble finalement. Donc merci pour tout. Je remercie tous les doctorants ou docteurs que j'ai rencontrés. Donc aujourd'hui Marie, coucou Marie, mais tous les autres qui sont en ligne. Donc je ne vais pas tous les citer parce qu'il y en a trop. Je vais en oublier, je suis désolé. Mais je fais un bisou en particulier à Tarek et Mohamed qui très tôt dans la thèse m'ont permis de prendre du recul vis-à-vis de celle-ci pour mieux, voilà, pour la vivre mieux, d'une manière générale. Donc, je fais un bisou en particulier aussi à Annès, à Nen et Nen. Bon, j'ai dit que je ne citerai pas tout le monde. Bon, désolé pour les autres. Enfin, merci tout le monde. J'embrasse fortement mes amis proches pour leur soutien et leur compagnie, leur amitié. Donc, Nicolas, Pauline, Johan et Aurélie, qui ne peuvent pas être là aujourd'hui, malheureusement, mais qui, je sais, sont en train de regarder. Morgane, Alexis, Guillaume, bien sûr, qu'il ne faut pas oublier, sinon je sens qu'il va me le reprocher les 10 prochaines années. Merci, Guillaume. Et bien sûr, tant d'autres. Bien sûr, je remercie toute ma famille qui m'a tout le temps supporté, en particulier mes parents, qui m'ont apporté beaucoup d'amour et beaucoup de confiance, ce qui m'a bien sûr aidé à devenir la personne que je suis et à réussir aujourd'hui à soutenir cette thèse. Donc, merci du fond du cœur. Et enfin, la thèse, ça a été une expérience très riche qui probablement aura façonné la façon dont je serai dans le futur. Mais maintenant, c'est fini. Mais il y a une chose qui n'est pas finie, qui a commencé durant cette thèse, c'est la rencontre avec une personne formidable qui m'a soutenu et supporté malgré mon caractère particulier ces dernières années. C'est Diana, ma chère Diana. Et donc, je te le dis avec mon plus bel accent russe, Yatibia Liupu. Voilà. Merci à tous.
Ok, très bien. Merci. Thank you everyone on the committee. Thank you Jean-François and Mehdi for inviting us, and hope to see you in the near future. Et bonne continuation, Romain.
Merci beaucoup. Merci à tous encore.
Félicitations. Bonne continuation.
Merci. Au revoir.
Au revoir.
Félicitations, Romain.
Faites bien.
Bye bye.
Je coupe. Allez, je coupe. Salut.